Hello guys, welcome you all to the sixth session of Pandas data frame. So first of all, I've created this day6.ipynb file. Thereafter, let's before starting this session, let me clarify you one thing. During the last session, which I have conducted, that is the day fifth session, I have wrongly said 10%, where it was actually a 1%. So kindly, it was just in the flow of the thing. I just keep on saying 1%, 10% instead of 1%. So please, it's a 1%, not the 10%. So you must be clear about it. Let me take you to this thing. And this is actually here I was doing some telling you 10%, it was actually a 1%. So I was, it's like that, everything is fine. Now let's come to the today's topic. So first of all, let's import these two libraries, Pandas and NumPy. Thereafter, read this nutrition data. Fine. So now let's do one thing. After this, what we were discussing in the last session, we have discussed how to take this sample, random sample from our data. And we have also studied about how to select this. What was one parameter? Can anyone tell me what was one parameter that I was using for if I want that both of us should get the same record or observation? So what was that parameter? Can anyone please tell me? So it means you people are not revising it. So there was one parameter called random underscore state. So if we select both of us, the random state is same, then we will get the same record or observation. Fine. Now, what is the agenda today that I am going to discuss? Let me clarify you this thing. Today, I am going to discuss how are random numbers generated. So yesterday we have just created this random sample, and today we are going to discuss this how random numbers are generated. So first of all, let me what we are basically going to discuss today. First of all, before discussion, take me one sample. SAMPLE sample, some random sample. So if I am asking it to give a random sample, it is giving me something like this. This is by one random sample. So basically, today we will discuss how computers generate random numbers. And we saw that the random method in Pandas chooses a random observation from our entire data set, or you can say from our population. Now, the question now is, how does Pandas actually decide this? That means, how does Pandas get random sample and it decides to give us the observation with the index level? So let's say this is an index level. In this random sample, I am getting this sample which is having this index 2821. If let's say, if I again do it, can you see this index number has got changed? If I will again do it, this, because every time I am getting a random sample, so the index value is changing every time. So what I mean to say, how does the Pandas get this random sample and decides to give us the observation with this index level? And then when we are calling this sample again, it gives us yet another observation which is having a different index value. Fine. So the answer to these questions goes beyond Pandas and Python and more into this computer science in general. See, when we observe random phenomena in the world, like radio noise, let me show it to you on. So I have made a Google search of radio noise, and this is the image of the radio noise you can see. So what I was talking about, that the question that how we are getting this observation or this random sample, this question goes beyond pandas and Python and more into computer science in general. So when we observe random phenomena in the world, like this radio noise, this is a radio noise, or you can say, or cosmic background radiation. You can see this here. If I will type cosmic background radiation, let's see, cosmic background radiation. This is the cosmic background radiation. I want to see the images of it simply. So let's see the image of this cosmic. This is basically a cosmic background radiation. You can see the image of these things. So we are witnessing what physicists call natural entropy. We know entropy, we have studied entropy in the physics. So entropy is basically what? Randomness. So think of this phenomena, this natural phenomena, as true randomness. So either if this is just an example that I want to give it to you of some natural phenomena, either you say radio noise, or you say this cosmic background radiation. These are basically random phenomena, and these are true randomness. So think of this as true randomness. And in simple terms, that means that what we observe now tells us nothing about what comes next. This is in simple terms. When we will talk about the natural phenomena of randomness, and you keep observing the same process and the same output, and we won't be able to get any predictiveness out of it. That means when let's say any natural phenomena which is very random in nature, you cannot predict what will be the next value, what will be the next thing that it will come. So this is what we mean by true randomness. This is actually a true randomness. But it's actually very hard to source this natural entropy due to measurement biases and rate limits. But there are many creative ways that scientists go about this. And one cool example is what these people uh, at random.org. There is one thing called if you will type random.org, let's see. This is random.org. Open it. Not opening. Okay. Random. Okay. This is random.org. So random.org, if you will say this, if you will come here to this random.org site, so there the people are actually measuring something very phenomena, and they are actually doing some, let's say if I will talk about this random integer generators. So these are some things which let's generate something, get numbers, 8 numbers. Okay. So here are random numbers in random integer generators. Can you see random integer generators? So here are your random numbers. So what actually they are doing, So these are, but there are some creative ways these that scientists are using, and this is simply one example of what how the scientists are using this random .org at this site, the random.org. They are using a lot of these things to give us the randomness, random value of the things. So I have the random integer generator here. But what essentially is happening is that they are collecting some atmospheric noise, which is yet another example of natural entropy. They collect that using a regular radio, and they utilize that stream of randomness to generate numbers and strings and names. And I think they even have even they are generating random drawings. They, in fact, they are, if you will see here in the drawing sections, if you will go, so they are also utilizing some random drawings of these some natural phenomena. So in fact, I have not got any chance to work with that, but it's quite interesting what they are doing here. So this is true randomness because at its core, it is supported by a natural phenomena, which to the best of our understanding is not predictable at all. You cannot predict it all. But the random numbers generated by computer are only pseudo-random. They are pseudo-random. What is this pseudo number random? Pseudo random means they are fake random. The reason for this is that our computers are very deterministic with the execution of probably with the exception of probably quantum computers, because quantum computers is very different from the normal computers that we are right now using. And in fact, I have never seen quantum computers, or I have never used quantum computers. But let's come to the our this thing. So I suppose you guys are having a good understanding of this. So the reason is that our computers are quite good at following the instructions or a fixed algorithm or a set of rules for generating the numbers. But they cannot on their own manufacture or create numbers. So what computer scientists have done is they have come up with highly intricate number generators, and that starts with some piece of input, and from where they deterministically or predictively generate a sequence of numbers. The catch is that these generators, which are known as basically these generators, which are basically known as, let me write it here. They are known as PRNGs. What these PRNGs are? PRNGs are pseudo-random number generators. So PRNGs, you can call this PSEU, pseudo-random number generator. Generator. So these generators which generate a random numbers is known as PRNGs, pseudo-random number generators. Means they eventually repeat themselves, but they are never truly as good as the natural thing. or natural kind, because the natural kind is true random generators. So they are not true generators. They are just a pseudo number. Pseudo means fake number generators. So both Python and Pandas via through numpy uses a variation of pseudo number generator called the Mersenne Twister. Let me write it here, this thing. Both Python and pandas via numpy use a variation of pseudo number generator, pseudo random number generator called Mersenne Twister. Fine. So what is this Mersenne Twister? So let me take you again to the Google. So I have searched it on the Google. I got this Mersenne Twister. This is basically, you can see Mersenne Twister is a general purpose pseudo-random number generator, PRNGs, developed in 1997 by Mokato Matsumoto, Takunzi Nishimamuru, whatever the name is. So basically the thing is that it was published by this Mersenne, something called Mersenne primes. So this is this thing was published by two Japanese researchers in 1997, that is the late 90s. But just like all PRNGs, this one too expects a seed. That means a starting point from where it then deterministically generates a sequence of random numbers. What does seed means? That means it also requires some starting point from where it starts generating a sequence of random numbers. So I suppose I have given you a very rich background of how this randomness and this random sample, from where it is all coming. Now let me take you to the our sample method. Let's come back to our sample method. So let's say if I will write this nutrition dot sample, and I am writing some random underscore state is equal to 19, and so I'm getting something like this. If you will also use this random state is equal to 19, you will also get the same value. So see, what we are effectively doing here is, the point to uh, uh, understand here is that we are locking down the starting input. So we are starting our PRNG from the same point. But because the PRNG is very deterministic, this sequence of number that it generates when fed this fixed random state will always be the same. That is why we guaranteed that whenever we sample with a given random state, we will always get the same number back. This is the reason behind why both of us, when we are putting the random state is equal to 19, why both of us are getting the same output. I suppose this is clear to you. So if you will, let's do it with some other, let's put some other random state here. So fine, random state is equal to 1, 3. Let's put it here. Yes, I got it. I got it, Varun. I got it. If I put this thing 4453, I'm getting this thing. So I will try to provide few more links to further. Uh, I will provide some links here at the end of this sheet, so that if you want to study something more about this thing, you can go to that link and you can read from there. So it will be better. But for now, that's all. And this is all that I wanted to discuss with you today. That what was my topic? How are random numbers generated? So that's all fine for the day. Let's push our code to the GitHub. So 6th session of Pandas completed. Oh, first of all, let's save the code. Save whatever we have done today. No, then commit it. Commit it. Sync changes. Fine, guys. So next, tomorrow we are going to discuss data frame access. So don't miss this session. It is going to be very important session in the data frame series. So let's meet tomorrow. Thanks for coming, guys. And thanks those of you who are watching the recorded session. Thanks, guy, for watching this session. Keep smiling, keep learning, and let's meet tomorrow.